Statisticians and mathematicians are not only concerned with the center of the data, but they're also concerned with the spread of the data, or how far apart their data values are within the data set. Because two very different data sets can have the same mean, statisticians also use measure of spread or variation to describe how widely the data values vary and how much the values differ from what is typical or what is the average. The most common of these measures are listed below. The range, which is the difference between the greatest and the least values of the data set. The variance in a set of data of all of our data scores, x sub 1 to x sub n, is the mean of the squares of the deviations or the differences from the mean. So what that means, I'm going to translate here, that this Greek letter sigma, and sigma squared is going to represent variance. The x sub 1, x sub 2, all the way to x sub n represents your individual data scores. And remember that mu represented the average. We got to square that. So we're going to take all of our data values, subtract the mean from it, square it, add it to the next score, subtract it from the mean square. We're going to do that with all of our data values, and then divide by n. Now the formula that we're looking at is for population variance. A population meant that we were able to take all the data values from the group of or individuals that we wanted to look at. So population rather than a sample, and we got to pay attention to that one versus sample, because population requires a little bit different calculation. Standard deviation, the simplest way to talk about standard deviation is it is the square root of variance. So once you find variance, to find standard deviation, you take the square root of your number that you get for variance, or the value that you get for variance. So standard deviation tells us how far an individual data score varies from the mean, or the average. So there are three ways to describe variance of a score spread of a data. And once again, this formula that we're looking at here, I just want to reiterate that this is for population standard deviation. Now, we got to pay attention to this, the unbiased estimator, dividing by n minus 1 instead of n, when finding a sample variance in standard deviation, gives us a slightly larger value and therefore an unbiased estimate of the population or standard deviation of variance. When you do a sample, you're probably going to have a little bit more error because you weren't able to sample the entire, something from the entire population. So you're going to use a smaller subset of objects or things to sample. And that way, if you use n minus 1, n minus 1 is going to be a smaller number in the denominator. So when you divide by a smaller number in the denominator, when this number is smaller, it gives you a larger value here in your final calculation. This one will be larger. So when you have a sample, you want to take into account that there may be some errors in the samples of the data that you've collected. So divided by n minus 1 gives you a little bit more of an unbiased estimate for the actual spread of the data. So let's try to apply some of these things in our second example. Two classes took the same midterm exam. The scores of 5 students from each class are shown. Both sets of data, or both sets of scores, have a mean of 84.2. So the average for both of these classes, the central tendency, or the mean of the data, is 84.2. Even though they have the same mean, they may have a different spread or variance within their scores. So in question A, we're going to find the range, variance, and standard deviation for the sample scores from class A. Now what's important to note is that these formulas that they were given to us up here were for population variances. And this is a population standard deviation. And this one, they're asking us for the sample scores from class A. So sample scores means there are more students than that in class A, but these were a sample of those in class A. So because we have a smaller subset of our actual class, we want to divide by n minus 1. So realistically, in this formula, we're going to replace the n with an n minus 1. And this n with an n minus 1, which isn't going to have a whole lot of impact. All we're going to do to find standard deviation is to take the square root of your variance. So we've got to keep that in mind when we go to our calculation. So the first one is relatively simple. In order to find the range, to simplify it even farther, I take the high score minus the low score in our data set. Our high score is 92, and our low score is 76. And you find the difference of the high and the low, it is 16. So the difference between the high and the low in our scores is 16 percentage points. The next one we're going to calculate is variance. So in order to calculate variance, we're going to use the Greek symbol sigma squared in order to calculate variance. Now there's a pretty good formula for this, and we're going to fill that in, but we're going to divide by n minus 1 because it is a sample. And now we're going to take each of our data scores and subtract it from the mean squared and add it to the next data score, subtract it from the mean squared, and we're going to do this until we're done with our data values. I'm going to slide over here and we're going to run our variance. Sigma squared equals. We want to take our first value in our data set, which is 85. This is our first score. We want to subtract our average, which is 84.2 squared. We want to add it to the second data value, which is 76 minus, we want to see how far it deviates from average squared plus. The third one was 92 minus our average, or central tendency, plus 88 minus our average, 84.2 squared, and plus our final score was 80 minus 84.2 minus squared. It's all divided by, and because it's a sample, it's going to be n. There are 5 data scores minus 1. Okay, so really that's going to be a 4 for us. Now we got to do some calculations here. In order to do calculations, we're going to utilize a calculator. Since we've got to use 84.2 over and over again, I'm going to store that value in a variable. So I'm going to put an 84.2 and I'm going to store it in alpha A. And now if I hit alpha A, it's a variable that stores that average of 84.2. So now I'm going to go along with the calculations. So I'm going to go parenthesis, I want an 85, I want to subtract the average, which is alpha A, and we want to square that value. So parenthesis squared, we want to add that to our next data score, which is 76, and we want to subtract from that our average squared, plus, and we keep going down the line. We have 92. Get my parentheses in there. 92 minus our average squared and plus, and then I needed an 88. And once again, I forgot the parentheses. 88 minus the average squared, and then plus our final one, which was 80, and 3 out of 3, forgot the leading parenthesis, 80 minus our average, and then squared. I'm just going to get that sum, which is 160.8. I'm going to record that. So now I've got sigma squared equals 160.8 divided by 4. If I remember if that number was right. 160.8, we want to divide it by 4, and that will be our sample variance, which is 40.2. So this is our variance. Alright, we only got one thing left to work on, and that is our standard deviation. So I'm going to grab our standard deviation. In order to get our standard deviation, what I want you to remember is it's always the square root of your variance. I got 2 E's instead of a C. And that's going to be your standard deviation. So standard deviation is the square root of the value you got from variance, which is going to be the square root of 40.2. So we're going to take the square root of 40.2, so second square root of our answer. It's the easiest way to get that number in there. And our standard deviation for our sample is 6.34. And a lot of times we'll go to the hundredths place on standard deviations and variance. Okay. So there's an example of what to do to find this range, variance, and standard deviation. Okay. Now in set B, question B, they want to use a calculator to find the range, variance, standard deviation for the sample score for Class B. So now I'm going to show you how to do this using your stat feature of your calculator rather than having to go through all the calculations by hand. So this will be an alternative. You should be able to work it both ways, both without the stat edit list feature of your calculator and with. So in order to do this, what we want to be able to do is we want to be able to put our Class B data into our stat editor. So we're going to hit our stat key, we're going to edit a list, and if your calculator is like mine, it may have some values in there. I'm going to go up to the top, make sure that the list 1 is highlighted. I'm going to hit clear so I can clear that list, and it clears out all of list 1. Now what I want to put in here are the values from Class B, so I don't want to miss that number. It's a 75. So I'm going to type in my 5 data values: 75, 85, 95, 98, and 68. Okay, so there's my 5 sets of data. Okay, so now I got them in there, so now we're going to go stat, and we're going to calculate one variable statistics, and we're going to hit enter. Now, depending on your calculator, in the 84 Plus edition, it says, where is your list? It's in list 1. That's where I want to leave it. Frequency, I didn't use a frequency list in it at all. Typically we do not. We don't have that large of data sets and weren't messing with that. So we'll calculate. Okay, now here's where we're going to have to start doing some interpreting of what we want to find. Okay, I'd like to describe what you're looking at under your one variable stats. On the X bar that you see right here, X bar stands for the mean of a sample. So this is your average, which we knew from the very given it was 84.2. The summation of X, that is the sum of your scores in Class B. The summation of X squared is the sum of these the sum of the squares of each score, and those we typically don't use. Here's where we finally find some of the information that we want. The S at X and the sigma X are your standard deviations. The sigma X is your population standard deviation, and the SX is your sample standard deviation. So since we're working with a sample, when we come down here, when we're answering this problem, find the range, variance, and standard deviation for the sample, since they're talking about sample, we have to use the SX for standard deviation. Okay, the N stands for the number of scores. There are 5. The minimum value was 68. Q1 is your first quartile. M is the median, is your middle score, the third quartile, and your max score. So you got a min and a max of 98 to 68. So we're going to start running some of our calculations here. Let's go ahead for this Class B. Let's start with the range. The range, now we can either get it from our calculator. We know that the max is 98, the min is 68. So it had a spread in the data according to the range of 30 percentage points. Now we can't get variance directly. I'm going to come back to variance, but there's a tight relationship between variance and standard deviation of a sample. As I said, when we do this, we're going to have to make sure that we recognize that since we have a sample, we want to use S of X, which is equivalent to 12.79 approximately. Well, if this is our sample standard deviation, which we're looking at, sigma is kind of the key to that whole symbol, but it's normally for population. Let's get to variance. Well, in order to get back to variance now, what we're going to have to do is we're going to have to take our sigma and we're going to have to square it. Since variance is sigma squared, we're going to take the sample variance, which is 12.79, and we're going to square it. So we'll take our 12.79 and square that. And that will be our variance. So our variance we'll record is going to be 163 point, and 1 or 2 decimal places we can go 5/8. Okay. So now that we compare the two data sets, we've got the spread of the of the relationships between set A and set B and range, variance, and standard deviation says compare the standard deviations of Class A and Class B. Well, Class A, if we look up here, had a standard deviation of 6.38, so let's go Class A, 6.38 standard deviation. Class B had a standard deviation of 12.79. So when we compare these, we can clearly see that the Class B has a much greater standard deviation, which means their scores, they're on average, their scores are more spread out. There's a lot more diversity among the scores and results of the test taking within those students. So typically that's not something that we want to see. We'd like to see low standard deviations where we're all scoring very close to the average and not being spread out. So comparing these two, which one has a smaller standard deviation? Class A, which means their scores are more tightly representative of the average.